Let's tackle another quadratic function where we have to find all the characteristics and then graph. As always, you got to figure out what form you are given for your quadratic. And in this case, we have a standard form because there are no parentheses. It is in the form ax squared plus bx plus c. So again, no parentheses. If I could spell it all. So no parentheses gets us to standard form. That means when finding the vertex, we're going to have a little bit more work to do. Remember that h is equal to negative b all over 2a. Looking back at my function, a is the coefficient of our x squared, which is 4. B is 8, and c is negative 5. So plugging in to find my h, I am going to have negative 8 all over 2 times a, which was 4, which gets me negative 8 all over 8. We find out that we have negative 1. Remember that k means that we take whatever number we found and we're going to plug that in. So we need to find h of negative 1. Remember that h is the same thing as f. We just don't call all of our children or all of our functions the same name. So f of negative 1 or h of negative 1, which means we have 4 times negative 1 squared plus 8 times negative 1 minus 5. Watch when you plug it in to your calculator, because if you don't include the parentheses around the negative 1 before you square it, you're going to wind up with a negative 17, which is incorrect. You should wind up with a negative 9. And we just found that our vertex, hk, is equal to the ordered pair, negative 1, negative 9. And that's our vertex. Our axis of symmetry is always in the form x equal to h. It goes through our vertex. It's a vertical line that cuts our parabola in half. So here we're going to have x is equal to negative 1. Because we have a quadratic equation, our domain is immediately negative infinity to positive infinity with parentheses around everything, because we don't put brackets around infinities. Whether or not our graph opens up or down comes from a, and here a is 4, which is greater than 0, or positive. And when you are positive, you are happy, which means you're smiling. And that means that our graph opens up. Because our graph opens up and we're smiling, that means that our vertex is hanging out at the bottom. And if our vertex is at the bottom, we have a minimum. So our vertex is the lowest point we can be. I'm going to skip my range and increasing, decreasing for a little bit until we look at the graph. If you want to know how to do that without looking at the graph, watch the videos where we just cover only the function, not graphing. Okay. We're going to do x-intercept, and to do that, I'm going to do my work over on the side because I know that it got really crowded last time. So our x-intercept, remember we find an x-intercept by plugging in y equal to 0, which is the same thing as setting our equation equal to 0. So we are going to take our equation. We have 4x squared plus 8x minus 5, and we're going to set that guy equal to 0. You know 3 different ways, at least, or right now, to solve a quadratic equation. You could factor, but almost every one I know hates factoring, except for mathematicians, and even then it's hit and miss. We can't use the square root property here because we have that middle term, the linear term, the x to the first. But our friend, the quadratic formula always works. It doesn't matter if you can factor or not. It doesn't matter if you're imaginary, if you're irrational, the quadratic formula doesn't care. It will always be there for you. Remember our quadratic formula if you don't have it memorized. So x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So plugging in the values that we already found when we were finding the vertex, we're going to have x is equal to the opposite of b, which we said was 8, plus or minus the square root of b squared, which will be 8 squared, minus 4 times a, which we said was 4, times c, which is going to be negative 5. Keep your sign on that c, all over 2 times a, which was the 4. When you do this in your calculator, you're going to take only what's in the radicand, what's under the radical, and simplify it. Okay? When you take 8 squared minus 4 times negative 5, you should get 144. So we have negative 8 plus or minus the square root of 144 all over 8. And then take the square root of 144 in your calculator. If it gives you a decimal, that means that you need to simplify using factor trees. If it gives you a nice whole number, yay, no more radical. When we take the square root of 144, we get 12, and it's a nice whole number, which means that we do not have a radical anymore. So we have negative 8 plus or minus 12 all over positive 8. We're going to break that into 2 separate answers. Our first answer will come from negative 8 plus 12 all over 8. And our second answer will come from x equal to negative 8 minus 12 all over 8. Okay. In the first one, negative 8 plus 12 gets us 4. X equal to 4/8 becomes 1/2. So our first answer is x equal to 1/2. And then our second one, negative 8 minus 12 gets us to negative 20 all over 8. And then reduce, you should get negative 5/2. We're supposed to write our answers as ordered pairs. Remember that we plugged in a y value. We're going to have 2 separate ordered pairs. These are not one ordered pair. Do you remember what we plugged in for y? Finding an x-intercept, we plugged in y equal to 0. So our 2 x-intercepts are 1/2 comma 0 and negative 5/2 comma 0. Yes, having 2 for a reason, because we have our highest exponent of 2. That's going to come into play later on. Part J asks us to find the y-intercept and write our answer as an ordered pair. Remember that our equation, scrolling up, was 4x squared plus 8x minus 5. So 4x squared minus 8x plus 5. And we need to plug in x equal to 0 to find the y-intercept. So we're going to have y is equal to 4 times 0 squared plus 8 times 0 minus 5. If we do all the multiplication, the 4 times 0 squared, it goes away because it's 0. 8 times 0 is still 0. We find out that y is equal to -5. And as an ordered pair, we know that the -5 is a y value, and we plugged in x equal to 0. So our y-intercept is 0, -5. Let's go ahead and graph this, and then we'll deal with the increasing, decreasing, and all of that wonderfulness. We had our vertex, if I scroll back up. Our vertex was -1, -9. All right, so -1, -9. It's going to be down here. We have 2 x-intercepts. 1/2, if we're looking at it, we're going to be directly in between 0 and 1. So our 1/2 is there. And that is our ordered pair, 1/2, 0. -5/2 as a decimal is -2.5. So we're going to go 1, 2.5. And labeling my ordered pair, -5/2, 0. All right. We also have our y-intercept, which is at the point 0, -5. 1, 2, 3, 4, 5. Oops, let's switch. There we go. Remember our axis of symmetry cut all the way through our vertex at x equal to -1. Okay. And by our axis of symmetry, since 0, -5 is 1 space away to the right, our other value, or its mirror, should be 1 space to the left, which means that we have the ordered pair, -2, -5. And we have enough to be able to graph our quadratic, connecting our lines. Make that a little bit better. There we go. Graphing, so much fun graphing. No, not really. Don't worry, I'm with you. Okay. Graphing is good for the visuals. I know it's tedious and obnoxious, but it's good for the soul. Okay, so there's our parabola, which means that we can now identify our range, our increasing, decreasing intervals. We can do it all. So our range, remember, is our smallest y value to our largest. And down here we see that our lowest point is at -9, which means our range is going to be from -9 to infinity, always parentheses around the infinity, bracket around the -9. And we need to figure out the increasing, decreasing situation. Remember that we read from left to right. So starting on the left, scrolling down, you can see that we are dropping down, which means that we are decreasing. And on the other side, after we hit our vertex, we start to go up. And since we're going up, that means that we are increasing. And remember that this all is based around that axis of symmetry. He's our turning point. So from our negative infinity on the left-hand side all over to -1, we're going to be decreasing. And from -1 to positive infinity, the other half of the graph, we are increasing. I'm going to write my increasing first since I can see that at the top of the page still. So -1 to infinity. And then I'll scroll up for decreasing, which we said was the first half of the graph, which takes us from -infinity on up to -1, remembering parentheses around everything for increasing and decreasing intervals.